Well, I'd like to welcome you all. Thank you for coming. My name is Andrew Becherer, and I am a senior security consultant with a firm called ISEC Partners. I have experience in web and mobile application security. I've recently had a focus in cloud computing. Last year, along with researchers Alex Stamos and Nathan Wilcox, I presented a talk called Cloud Computing Models and Vulnerabilities Raining on the Trendy New Parade. And in that talk, I focused on infrastructure as a service cloud computing models, and specifically threats to random number generation and the generation of entropy in infrastructure as a service cloud computing providers. So today we're going to be talking about Hadoop, and this is our agenda. I'm going to start with a conclusion, and I'm going to talk about Hadoop at just the most extreme high level for those of you in the room unfamiliar. And then we'll talk about kind of the old school Hadoop risks. What did things look like before the core developers started implementing a security feature set? Then we'll talk about the new approach that the core developers have taken. I will enumerate my concerns. We'll talk about one alternative strategy, and then we'll talk a little bit about what to do if you are a security consultant and you come across Hadoop on a network that you're pen testing or as part of an application that you're reviewing. So let's start with the conclusion. Why am I starting with the conclusion? Well, I really feel like we need to clear the air, right? I was going to answer a question here. I was going to say, did Hadoop get any safer? And what I'd say is they built a foundation, right? That's kind of a weasel, but originally the only way to safely deploy Hadoop was with extreme and strict network segregation. And so now the only way to deploy Hadoop securely is with extreme and strict network segmentation. So, but they're on the right track, right? They've built a foundation, and I think there's a lot of material to work with. Some of the gaps are in the design, some in the implementation, and some in the documentation. But it's headed in the right direction, I think. So let's talk about Hadoop. All right. So, what is Hadoop anyway, and why do we care about it? Why am I standing up here? Why is it of interest? Let's take a really simplified view. So for those of you who are just completely unfamiliar with Hadoop, Hadoop is an alternative to the SQL orthodoxy that has dominated application development for millennia, right? It's one of these kind of NoSQL type alternatives to SQL. And so organizations that have petabytes of data use Hadoop to analyze that data. So in the Apache Foundation's Hadoop project, there is the Hadoop file system, which is made up of data nodes and name nodes, and they give data access. And then we have the MapReduce engine, which is made up of two primary components, and that is there's the job tracker. Users submit jobs to the job tracker, and those are assigned to task trackers, which are as physically close to the data as possible. And this is very important for Hadoop performance. And then while these are the primary components of a Hadoop cluster, there are other optional services like workflow managers, of which there are several now, or bulk data distribution, which is used to even out data distribution across the cluster, because it's essential to performance that data is replicated. So this is a simplified view that neither breaks things down well along functional lines nor along machine boundaries, but it's just intended to kind of give you a map of what Hadoop looks like. So we've got a user talking to a job tracker, and that's kind of the edge of Hadoop, right? Users interact with that job tracker, and then the job tracker communicates with task trackers. Task trackers communicate with HDFS. HDFS can be subdivided down into the individual nodes. So Hadoop is in use at many of the world's largest online media companies, including Yahoo, Facebook, Fox Interactive Media, LinkedIn, and Twitter. Hadoop is entering the enterprise, as evidenced by Hadoop World 2009 presentations from Booz Allen Hamilton and JP Morgan Chase. And Hadoop is making its way into the federal government. Last year, the NSA disclosed that they're using Hadoop in a system for intelligence analysis and to link disparate sources of intelligence data. So as you can see, Hadoop has come a long way from when it backed an open source search engine which was storing public data. Back then, there was no reason for a security model, but things have changed considerably. So let's talk about the Hadoop that was, right? Why was all this effort expended? Hadoop did not have a security model. As I said, it backed an open source search engine. It was generally used for public data. And so what I'm about to talk about are the old school risks to Hadoop and what the developers are trying to mitigate now. So one thing is Hadoop performed insufficient authentication. It didn't authenticate users properly. It didn't authenticate services properly. The Hadoop file system, the way it worked is the client would basically use the Unix who am I utility, right? And it would find out that the user is Bob, and then it would over the network request Bob's data. So an attacker just as easily as Bob's client could say, hi, I'm Bob, give me Bob's data. So as you can see, HDFS file permissions were easily circumvented. And the only thing that really stood in the way, that the attack wasn't quite that simple because attackers needed to discover a particular piece of data. It has a block ID associated with it. If this block ID was discovered, then you could access the data. That's not an extremely high bar, right? That's complexity. That's not actually a security boundary. And also, write access was not limited in any way. So there wasn't any privacy and no integrity either because there were not secure transports in use. So information could be sniffed on the network, information could be modified. So we can see there are some issues there. Arbitrary code execution. So because there was not sufficient authentication or authorization, pretty much anyone could submit code to a job tracker, which would then be executed with the level of permissions of that job tracker, which was generally a fairly privileged user on that physical host. So this is the legacy that Hadoop has. And so what does this mean? What are these particular threats, these particular risks, right? So let's say Alice has access to a Hadoop cluster and Bob has access to a Hadoop cluster. Alex and Bob have to trust each other completely because either one can impersonate the other. But if Mallory gets access to the cluster, Bob and Alice, they both die in a fire, right? It's that bad. There is no security in place. So let's talk about the new approach. What are we talking about here? Because in 2009, the discussion about Hadoop security really reached a boiling point. And there were a number of talks at Hadoop World this past fall about security, a number of approaches. And so the core developers of the Hadoop project decided that they were going to perform strong mutual authentication of users and services. But it was going to be transparent to end users, right? And also they were going to help everyone out and introduce a new workflow manager called Uzi. And so that's what we're going to talk about now. So to quote the developers, or actually probably some PR person somewhere, this update integrates Hadoop with Kerberos, a mature open source authentication standard. Right? So the developers chose to use Kerberos via GSS API to authenticate to edge services. I was talking about the job tracker earlier. When a user connects to a job tracker, they're authenticated, and then the operating system principals are matched to a set of user and group permissions. These user and group permissions are stored in flat text files on the job tracker. So as you can see here, it depends on the strength of your Kerberos deployment to some extent, and so I would encourage everyone to see the presentation that was given yesterday about attacking Kerberos. I think they'll explain how simply adding a dash of Kerberos does not magically make a secure network. So it wasn't feasible to meet their performance requirements to use Kerberos completely. Internal to the cluster between name nodes and data nodes and the job tracker, they use various tokens, right? They don't want the KDC to become a bottleneck. So each of these tokens is extremely similar in structure and relies on HMAC SHA-1. So delegation tokens get used to connect to the name node in order to gain access to data that's stored in HDFS. Block access tokens are used to secure communication between the name node and the data nodes, and that's actually where HDFS file system permissions are enforced because file system permissions in a distributed file system like HDFS it's an extremely difficult problem. So they try to provide a gateway that performs those checks. And then finally, the job token is used for communication between the MapReduce engine task tracker and individual tasks that are operating. It's important to note that, so we're talking about symmetric encryption here, right? We're talking about HMAC SHA-1, and so there's a shared key involved, and this shared key is going to have to get distributed to tens, hundreds, thousands of hosts, right? And so it's going to depend on how the key is distributed, correct? So there were some limitations stated when this design was introduced, and this comes from the Hadoop security design paper, which was released by Owen O'Malley and his fellows at Yahoo. And so one thing they said was the degradation of grid mix performance, and that's just a specific performance benchmark for Hadoop, should be no more than 3%. So they're extremely sensitive to performance hits. Users will not have access to root accounts on the cluster or on machines that are used to launch jobs. We talked about all that symmetric crypto that would fall apart if users could steal the shared keys, right? And HDFS and MapReduce will not travel over untrusted networks, and so this is key, right? They're by default they're going to be using unsecured transports, and they say, well, you know, trust your network, and that's essentially what we had to do before. We had to trust our network. Now we have to trust our network. So what are my concerns? I have a number of concerns, but chief among them is a poor default Kerberos quality of protection, which I'll explain, the symmetric cryptography in use, an incomplete implementation of a pluggable web UI authentication scheme, and then also the use of IP-based authentication. So we talked about the performance concerns that the developers had, and the default Kerberos quality of protection is set to authentication only. So communication between the user and the job tracker will just be authenticated, and it does not protect the privacy or the integrity of that communication. So there's kind of three options you have: authentication, integrity, privacy, and they've chosen authentication. And now it remains to be seen that there is support in the code, although it requires further analysis for using integrity and privacy here, although it remains to be seen how changing this setting will impact this digest RPC scheme that's being used with the various delegation tokens. So the symmetric cryptography, so it's relying on HMAC SHA-1, right, which is a cryptographic hash function in combination with a secret key. And so for the example of a block access token, there will be thousands, or well, depending on the size of your cluster, right? I mean, clusters there are organizations with 30,000 plus nodes split across 20 clusters, right? So you're talking about thousands of hosts. These keys get transmitted in clear text over the network, and also they get rekeyed from time to time. So if you miss it the first time, keep listening, right? And then there's the issue of pluggable web UI authentication. One thing I have not discussed to this point is that a number of the nodes and services in Hadoop have user interfaces, web user interfaces. And so how do you authenticate to these? That's a really important question. And unfortunately, that hasn't been implemented. There is a pluggable web UI mechanism, but what that means is if at your company you're going to start using Hadoop and you need to protect the web UIs, you're going to have to write your own pluggable web UI mechanism. So the Hadoop developers have, expressed interest in having someone write one based on SPNego, right? So they could use Kerberos. But there are some challenges there as far as browser support and configuration and whatnot. So right now, there is no standard web UI authentication mechanism for Hadoop. And finally, IP-based authentication is in use. In some Hadoop deployments, there will be the use of what are called HDFS proxies, and HDFS proxies will distribute data across a Hadoop cluster, which is essential for performance. But the Hadoop platform uses the proxy's IP address and a database of roles in order to perform authentication and authorization. And I think we can probably all agree that IP address is not a strong means of authentication, or at least I hope we can. So what are some alternative strategies, right, if this particular strategy isn't working? Well, One we can discuss is Hadoop over the Tahoe least access file system. So Tahoe LAFS is an open source decentralized data store that attempts to preserve privacy and security even in the case where individual nodes are compromised. So this really deserves its own talk, and unfortunately I won't have time to go too deeply here, but Aaron Cordova gave a talk about his Hadoop over Hadoop over Tahoe approach, and actually you can download it from Google Code where he has a project set up. But what's really interesting about Hadoop over Tahoe is that it's intended to be used in infrastructure as a service cloud computing environments. So in those environments, your physical disk isn't really a physical disk, right? So how can you really trust it, especially if you don't have insight into your particular infrastructure as a service provider's network and infrastructure? So let's not trust the disk, right? And the network can't be trusted either because if you're contracting the services of some infrastructure as a service provider, how do you actually know what's going on behind the scenes and that your communication can't be sniffed or modified by some malicious third party? And so what happens here though is that making those security guarantees has a cost. And that cost is that write performance is severely impacted. But fortunately, read performance comes through pretty well. So, especially in a number of use cases, read performance is significantly more important than write performance. So for some users, this is a legitimate approach. But I just find it really interesting because I think there are a number of ways we can go about securing Hadoop, and this is an alternative strategy. So let's say you are a security consultant and you wander into your client and performing a network pen test or some sort of application assessment. What should you focus on when you walk in the door? Well, so these are your targets. The topic of a workflow manager, this is a very open question. There are multiple workflow managers. Yahoo would probably like to see Oozie become the default. And Oozie, in order to perform its job, it's a super user, and it can impersonate any user in the Hadoop cluster. So if you can compromise the machine that Oozie is running on, you just took control of the entire Hadoop cluster. And also remember that the web UI authentication for Oozie has not been implemented yet, and may be implemented by your client, and may be implemented poorly by your client. So it's an area that should receive special review. Also, the name nodes and data nodes. So, why would you want to rob the data nodes? Well, that's where the data is. The money is. The data, right? And so, what you want to look for here is those secret keys. And so keep listening, and maybe you'll get one, or maybe you'll find a misconfigured box, misconfigured in some other way you can gain access to. Insecure data transports. This is going to be a problem for most Hadoop users. Most will have if they are using Hadoop with security, they will be using the default quality of protection of authentication only. And there's currently no guidance on running Hadoop with transport security or with message level security. And finally, these HDFS proxies. If you find a deployment with these HDFS proxies, remember they're doing IP-based authentication, and could be a way to gain access to all of the data stored in HDFS and very quickly. And then there is the issue of the tokens, which we discussed. And so all of these sensitive tokens must be protected when they're transmitted over the network, but they probably aren't. And they're useful for varying lengths of time, and without the ability to renew the tokens, you're going to be limited to, you're going to be time boxed to, 24 hours or less. But look for them. They're very useful. These are kind of in descending order of what I consider importance, with the delegation token, being really powerful, since you can communicate to the name node and get access to data that way. The name node knows where all the information is. The block access tokens are useful, but require additional effort to locate data, and the job token is equally useful. So Hadoop is increasingly used at very large scale. We're not going to see these approaches to distributed computing going away anytime soon. And Because of the sensitive data of much of the information we store in our networks, we're going to require stronger security guarantees than Hadoop can currently make. Right now, it still requires either a significant investment on the part of the person who is deploying Hadoop, or requires equally strong network segmentation. So this is going to be a really exciting area to watch, and I hope you all have enjoyed my talk. I'll take questions off of the podium, and thank you for coming.